Hashtag, what if you fell into a black hole? Imagine you're floating through space when suddenly you see something impossible. A region of darkness so powerful that even light cannot escape it. No stars shine from its center. No reflection comes back. It looks like an empty hole in the universe. But it's actually one of the most extreme objects ever discovered. Now, imagine that you're falling toward it. At first, everything seems strangely normal. Your spaceship is still working. You're still breathing. The stars are still shining around you. But as you get closer, something begins to feel wrong. The universe itself appears to be changing. So what would actually happen if you fell into a black hole? Would you instantly die? Would time completely stop? Would you be stretched into a thin stream of matter? And could you somehow survive long enough to see what is on the other side? Today, we're going to follow you from the moment you approach a black hole all the way to the terrifying point where our current understanding of physics begins to break down. Welcome back to Future and Facts Hub. Today, we're going somewhere humans have never been before. Deep into a black hole. Let's begin. Imagine you're traveling through space and a black hole suddenly appears in the distance. Technically, it doesn't simply appear. Black holes form when massive amounts of matter collapse under gravity, often after the death of a massive star. Some black holes can have only a few times the mass of our sun, while supermassive black holes can contain millions or even billions of solar masses. And the closer you get, the stronger their gravity becomes. But here's the strange part. A black hole doesn't work like a giant cosmic vacuum cleaner. It doesn't automatically suck everything around it into oblivion. If our sun were magically replaced by a black hole with exactly the same mass, Earth would still orbit at almost exactly as it does today. The real danger comes when you get too close. As you approach the black hole, you would see something incredible. The background stars would begin to look distorted. Light traveling near the black hole would be bent by its enormous gravity. Stars that should normally appear in one location could seem to move. Some light could even travel around the black hole, creating strange rings and warped images. The black hole would essentially turn the universe into a gigantic cosmic funhouse mirror. And then you would approach the most important boundary of all, the event horizon. The event horizon is not a physical wall. You wouldn't crash into it. You wouldn't see a glowing line floating in space. It's a boundary in space-time. Once you cross it, there is no known path that takes you back out. Not even light can escape. And this is where things become truly strange. From your perspective, you could cross the event horizon without experiencing a sudden explosion or impact. If the black hole were extremely massive, the gravitational forces at the event horizon could actually be relatively gentle. But someone watching you from far away would see something very different. Because of the effects of extreme gravity on time, they would see your movements becoming slower and slower as you approach the event horizon. Your signals would become increasingly delayed and stretched toward longer wavelengths. Eventually, you would appear to fade away. To the distant observer, it could look as if you never quite crossed the event horizon. But from your own perspective, you would continue falling. And that difference is one of the strangest predictions of Einstein's theory of relativity. Time isn't the same everywhere. Gravity can affect the passage of time. The stronger the gravitational field, the more dramatically space-time becomes distorted. So while your own clock might continue ticking normally as you fall, an observer far away could measure your clock as running increasingly slowly. This doesn't mean you personally feel time slowing down. Your heartbeat would still feel normal. Your thoughts would still feel normal. Your watch would still appear to tick normally. But the universe outside would behave very differently. And then you cross the event horizon. There is no alarm, no explosion, no giant cosmic doorway. You simply pass a point beyond which escape is impossible. At this moment, you have entered a region of space-time from which every possible future direction leads deeper into the black hole. And now comes the terrifying part. The black hole's gravity begins pulling different parts of your body with different strengths. Your feet are closer to the black hole than your head. That means gravity pulls harder on your feet. As the difference becomes extreme, your body begins to stretch. This phenomenon has a terrifying name: spaghettification. Yes, you could literally be stretched like spaghetti. But don't worry, you probably wouldn't have time to complain about it. As you fall deeper, the gravitational difference between different parts of your body can become enormous. Your body would be stretched lengthwise while compressed from the sides. Eventually, the forces would become strong enough to destroy the structures that make up your body. Atoms themselves could be torn apart. But here's where black holes become even more fascinating. The experience depends heavily on the size of the black hole. If you're falling toward a relatively small stellar mass black hole, the tidal forces near the event horizon could be enormous. You could be torn apart before or around the time you cross the horizon. But if you're falling toward a supermassive black hole containing millions or billions of suns, the event horizon could be enormous. The gravitational gradient at the horizon could actually be much weaker. That means you might cross the event horizon of a supermassive black hole without immediately noticing anything unusual. You could cross the point of no return while still physically intact. And that's one of the most terrifying possibilities, because you wouldn't necessarily know the exact moment when you became trapped. You could look around. You could see distorted stars. You could check your instruments. Everything might appear strangely normal. But outside your spaceship, the universe is no longer somewhere you can return to. The black hole has won. If you're enjoying this journey into one of the darkest mysteries of the universe, make sure to subscribe to Future and Facts Hub, because we're going to keep exploring the questions that sound impossible until science gives us an answer. Now let's continue. Once you're inside the event horizon, the situation becomes fundamentally different. In normal space, you can choose which direction to travel. You can turn left. You can turn right. You can accelerate. You can stop. Inside a black hole, according to general relativity, the geometry of space-time becomes so extreme that moving toward the center becomes as unavoidable as moving forward through time. You cannot simply turn around and fly back toward the event horizon. Even if your spaceship had an unlimited amount of fuel, there would be no conventional escape route. You could fire your engines. You could try to move sideways. You could point your spacecraft in any direction you want. But every future path still leads deeper into the black hole. And then you would encounter one of the biggest mysteries in modern physics: the singularity. According to classical general relativity, the center of a black hole contains a region where matter is compressed to an extreme state and space-time curvature becomes effectively infinite. But here's the problem. When physics produces infinities, it often means our theory has reached its limit. We don't currently have a complete theory that combines general relativity with quantum mechanics. So we don't actually know what the ultimate interior of a black hole looks like. This is where science has to say something incredibly honest. We don't know. Maybe the classical singularity really exists. Maybe quantum gravity replaces it with something completely different. Maybe space-time itself has a structure we haven't discovered yet. And this leads to one of the most famous questions about black holes. What happens to information? In quantum physics, information is fundamentally important. But if something falls into a black hole, and the black hole eventually evaporates through Hawking radiation, what happens to the information contained in that matter? Does it disappear? Is it somehow encoded in the radiation? Does the black hole preserve information in a way we don't yet understand? This is known as the black hole information paradox, and physicists have been debating it for decades. But let's return to you. Imagine that somehow your spacecraft survives longer than expected. You continue falling. The outside universe becomes increasingly distorted. Light from distant stars could appear concentrated and warped around the black hole. Your view of the universe could become completely unfamiliar. And eventually, according to classical physics, you would reach the central region. At this point, our current theories stop giving us a reliable description of what happens next. There is no scientifically confirmed portal. There is no confirmed wormhole. There is no proven alternate universe waiting on the other side. Those ideas exist in theoretical physics and science fiction, but we don't currently have evidence. that a person falling into a black hole would emerge somewhere else. So if someone tells you that black holes are definitely portals to other dimensions, that's not established science. The truth is much more mysterious. We simply don't know what the ultimate interior of a black hole is like. And that uncertainty is what makes black holes so fascinating. But there's another terrifying question. Could you ever escape? The answer, according to our current understanding, is no. Once you've crossed the event horizon, escaping would require traveling faster than light relative to the surrounding space-time. And according to Einstein's theory of relativity, objects with mass cannot accelerate beyond the speed of light. So the event horizon really is a point of no return. But what if you stayed outside the event horizon? Could you survive there? Possibly, if the black hole is far enough away. You could orbit it just like planets orbit stars. In fact, black holes can have accretion disks made from gas and dust spiraling around them. That material can become incredibly hot and emit enormous amounts of radiation. So, ironically, one of the brightest objects you could see in the universe could surround one of the darkest. The black hole itself doesn't shine. The material falling around it can. And if you were anywhere near an active black hole, radiation would likely be a far more immediate threat than gravity. This is one reason black holes are not places you'd ever want to visit. Now imagine you're watching from far away as your friend falls toward the black hole. You see their spaceship approaching the event horizon. The clock on their spacecraft appears to slow down. Their signals become weaker. The light shifts toward red. Eventually, they become extremely difficult to see. Then they disappear from your view. But from your friend's perspective, they didn't freeze. They crossed the horizon and continued falling. Two observers can experience the same event in radically different ways. Because gravity changes how time and space are measured. And this isn't just science fiction. Time dilation has been experimentally confirmed in weaker gravitational environments and at high speeds. Black holes simply push these effects to their most extreme limits. So what would really happen if you fell into a black hole? The short answer is this. You would eventually be destroyed by the extreme gravitational environment. But exactly how and when would depend on the black hole's mass, spin, and structure. A smaller black hole could tear you apart near the event horizon. A supermassive black hole might allow you to cross the event horizon before tidal forces become fatal. But once you're inside, escape would no longer be possible. And what happens at the deepest point? That's where our knowledge ends. Perhaps someday, a complete theory of quantum gravity will tell us what lies beyond the equations. Maybe it will reveal that the center of a black hole isn't a singularity at all. Maybe it will completely change our understanding of space and time. Or maybe the universe will remain stubbornly mysterious. And honestly, that's what makes black holes so incredible. They aren't just giant objects floating in space. They're natural laboratories where gravity, time, matter, and the very structure of reality are pushed to their absolute limits. Every time we study them, we're learning something about the universe itself. So the next time you look at the night sky and see thousands of stars shining peacefully above you, remember this. Somewhere out there, there may be a region where stars disappear, time behaves strangely, light bends around itself, and the normal rules of intuition completely break down. A place where crossing an invisible boundary means there is no way back. A black hole. And if you ever find yourself falling into one, there's only one thing you can be certain of. The universe is about to show you something that no human has ever survived to describe. This is Future and Facts Hub. If you enjoyed this journey into the unknown, subscribe to the channel and turn on notifications. Because there are countless mysteries hiding in the universe, and we're just getting started.